In this lecture, we'll take a look at how we determine the efficiency of algorithms. Finding algorithms to solve problems is an important part of computer science. In fact, as long as the algorithm is correct, we can use it to solve that problem. That also means that we could have several correct algorithms for a particular problem. So they'll all work, but the question we have to ask is any of them better than the others? I mean, I could have 2 or 3 algorithms that solve the same problem, but are they all equally as good, or is one better than the other? So what we're going to be looking at here are some of the properties or the characteristics that would make one algorithm better than some other algorithm that solves the same problem. We'll start by taking a look at some of the attributes of algorithms. First and foremost, we expect our algorithms to be correct. Now, by definition, our algorithm should produce some results and then halt. But this isn't enough. We can't just have it produce any result and say, okay, we have an algorithm for this problem. You might think this is very obvious that, well, of course it should produce a correct result, but it is worth emphasizing that we have to make sure that our algorithm is correct. I mean, we could have a very elegant, a very efficient algorithm, but if it gives us the wrong results, well, that doesn't do any good. In fact, it could make matters worse, because if the algorithm is incorrect, it can become very expensive. It can lead to mistakes. It could cause errors in our computer. It can cause some serious damage if our algorithms are not correct. So we have to make sure that they're correct. Okay, well, how do we do that? Well, not to be a cop-out, but determining whether or not an algorithm is correct really isn't a simple task. So what are some reasons that our algorithm could be incorrect? Well, one possibility is that it does produce the correct results, it's just for the wrong problem. And this can happen whenever we design an algorithm without a thorough or a complete understanding of the real problem that we're trying to solve. In fact, this is actually one of the most common causes for incorrect algorithms. Another possibility is that we understand the problem and the algorithm does provide correct results for some possible input values, but it doesn't work for all possible cases. And that just simply means that we did not check all of the possible cases. Now, can we really check every single case to see that it would actually work? No, it's unrealistic to check every single case, but there are some special cases that we should be able to consider, and there are ways that we can show and prove that our algorithm is correct for all cases, but we do want to make sure that we check as many special cases as possible to make sure that we're not missing something. Now, once we have a working algorithm or solution, we're not really done. I mean, most other theory-based disciplines would say, okay, we have our solution, end of story, move on to the next problem. But in computer science, we want to take a look at how we can make it better. We want to make sure and ask ourselves, is this the best solution for this problem? So there are other attributes we need to consider when we're designing algorithms. One attribute to consider is program maintenance. I mean, once we have a problem solved, we may need to make changes to it. I mean, programs are constantly being updated. It may be to fix some bugs. It may be to add additional features. We may be upgrading hardware or operating systems, but we're always in this constant state of making modifications to our programs. So we got to consider how easy is it going to be to make changes to our algorithm to fit those changes. Another thing we need to consider is the ease of understanding. So I mean, if we're going to make changes to our algorithms, we have to make sure we understand it. Not only do we make sure that we understand the algorithm, but we have to make sure that other people are able to understand the algorithms. I can't count how many times I've seen papers where there are these very efficient algorithms, but they were so complex and they're so complicated that it was very difficult to actually understand what's going on with the algorithm. In fact, with those types of papers, I seriously doubt anyone is going to actually use these algorithms. That's another whole point of making sure that we design our algorithms correctly, is these are not just theoretical results. they're actually going to be used. People are going to write programs based on these algorithms. So it's important to make sure that other people can understand the algorithms so that they can be implemented and used in a real world setting. Another attribute we should consider is the elegance of the algorithm. So here we're talking about, well, how clever did we write a solution? I mean, there are some solutions that could be very simple and they work just fine, but there every now and then you'll see this one algorithm that's just like, wow, that's a really clever way to solve that. Wish I had thought of that. I can't count how many times I said I wish I had thought of that particular algorithm, but that is another attribute to consider. And then the last one we'll talk about is efficiency. So here we're talking about the algorithm's use of resources. So not only do we need to consider the correctness, the ease of understanding, and the elegance, but efficiency is a very desirable attribute. So here, different algorithms could be faster and use much less resources than other algorithms. And these are more popular algorithms. So if I have two different algorithms to solve the same problem, if one is faster and uses less resources than the other, I'm probably going to pick that algorithm over the other just because we're not using up as much resources, because it's much faster. And of all the attributes that we've considered, besides correctness, of course, the efficiency of an algorithm is one of the most important attributes when designing an algorithm. So if the efficiency of an algorithm is important, well, how do we determine that one algorithm is more efficient than the other? Or how do we measure efficiency? Well, we take a look at two different areas. So we first take a look at efficiency in terms of space. So we have our input data, and that already requires so much space, and we're not going to worry about that, that space. But we consider the additional information that's stored on top of the input data. So how much more space do we need in order to solve this problem? So maybe we might have some temporary variables that we need. We may need to store some more things in order to solve the problem. But we take a look at how much more space is required to solve this problem. The other metric that we take a look at is the time. So how long does it take to solve the algorithm? Now you might think, okay, well, we'll just take a stopwatch and we'll just start and see how long it takes. Well, this doesn't quite work. We can't just count the number of seconds because the time may vary by computer. We may have two different computers and it may be faster on one machine than the other. And then you might think, well, okay, that means this algorithm is faster. Well, no, it just means it's faster on that machine. So we can't really consider the time in terms of number of seconds. So instead, we take a look at how much work is being done by the algorithm. And usually we do this by looking at the number of steps. Now you might think, well, does that mean we just count the number of steps? And if one algorithm has 50 steps and the other algorithm has 100 steps, then that means the 150 steps is faster? Not necessarily. But we look at the total amount of work done. How much work is being done at each step? And later on, we're going to take a look at how do we determine how much work is being done at each step. And that's going to give us a better idea of how long our algorithm is going to take.